I should hear.
Still is this board.
We'll start with a round. We'll have you. Everyone goes way over 5 minutes, but we try to keep the first rounds just your general thoughts. And,
Yeah. Is Ute coming?
I believe she'll be there. Yeah.
Jo l'he picat i el meu... Vale. Aquí hi ha un botonet encès, espera. S'ha d'haver-hi un, a alguna banda. Ara. Aquí hi ha el botonet vermell.
Okay, I think we'll begin. Yep. Okay, welcome to the plenary roundtable. This session is on challenges and opportunities in scientific literacy in formal and informal education. And so that's a really exciting topic. It's very broad, but we have an incredible panel of diverse and expert views that we can bring to the table to think about how can we cultivate scientific literacy in the evolution education space. And so what we'll do today, we'll start with just a round of introduction to our panel members. If the IT people can help get Ute Harms, if she's going to join us on Zoom. Hello, Ute. What we'll do is we'll begin with a brief round of introductions. I'll let the panel members introduce themselves. And then we'll do 2 rounds of short answer questions where we encourage audience questions to follow up. And then we'll have a more open and longer form discussion on any of the issues that might arise. So I guess we can just go, let's just imagine that Ute is sitting in the middle here. So we can just go down the line. And so maybe we can begin with you, Sílvia.
Okay, thank you very much, and thank you very much for inviting me here. I suppose, in short, I have to say I'm a teacher. Okay, I'm just a teacher. I was years ago a scientist, but I've been a secondary teacher for the last decades, and currently I'm already teaching in the pre-service teacher's master in the University Politécnica of Cataluña. Okay. I have just to ask for excuses because I'm not a biologist. I'm a quantum chemist like Angela Merkel. I think not too many similarities, but that was one. And the other is that, in fact, I've been teaching biology sometimes, but my main subject is engineering. Anyway, I've been working with a lot of interdisciplinary projects. That's one of the things I suppose I'm here for. And the second is I'm currently working in a coordination in a program where we make a link, where we organize partnerships between research centers, some of them evolutionary research centers, and primary and secondary schools. And I think that's the presentation.
Great, thank you very much. Ute, for many of you just saw Ute's great presentation, but perhaps you can also just, for those who might not have been here, introduce.
Okay. Okay, my name is Ute Harms. I'm sitting here in the north of Germany in sunny weather, even though I would have preferred to be in Barcelona, but my personal situation is that I couldn't come. I'm very sorry about that. I'm working at the IPN. It's an institute that is doing empirical research, focusing on quantitative research about science education and mathematics education. And do you still hear me? Because it changed here, my view.
I believe it's okay.
It's okay.
It sounds okay.
And from a start, I did my PhD in cell biology, and I taught biology for several years in high school, but also at university. And today I have different research focus, and learning and teaching evolution along the lifespan is one of my focus. And I just did my keynote about 3 of our projects. And yeah, I'm very much looking forward to our discussion now.
Great, thank you very much. Josefa?
So good morning, everyone. Let me thank the organizers. I know how hard you have worked to put this together, so thank you. So I'm an evolutionary biologist by training. My whole career I've worked on genome evolution from different perspectives, but always from a genomic point of view. I'm currently a group leader at the Institute of Evolutionary Biology here in Barcelona. And our research tries to understand how organisms adapt to the environment from a genetic point of view. So we want to understand the genes that are behind these adaptive characters, and also from a mechanistic point of view. So we also want to understand how changes in the genome happen.
Great, thank you. And Kostas?
Thank you. I'm Kostas Kampuragis. First of all, I'd like to thank the organizers for the invitation for this panel and the talk right after that. Officially, I'm a science educator. I work at the University of Geneva. I was a school teacher for 12 years in Greece. And my main research interests are in the teaching of evolution, genetics, and nature of science. I was the editor-in-chief of Science and Education for 5 years. And I've also started 2 science education book series with Springer. But I also have a parallel career as an author and editor. So I think I've written already 11 or 12 books, I don't remember, but only one is in science education, because I'm also interested on conceptual issues in science. And I'm going to mention a few in my talk right after that. And I have managed to bring together many scientists to contribute to a new series published by Cambridge University Press called Understanding Life, about topics in science for which there are many misunderstandings.
Great, thank you. And so, as Kostas mentioned, he'll have a talk right after this. And for those of you who were here, Ute gave a talk just before, and I think there's a great conceptual thread that we might be able to follow about this concept of scientific literacy and the aims of evolution. So we'll begin by going into just some short questions to get some things on the table and get us going. So the first short questions, and again, we'll try to keep 3 to 5 minutes of response approximately. So the first question is about scientific literacy. What is scientific literacy in the evolution space for you? So how should we define or think about scientific literacy in relation to evolutionary concepts or evolutionary thinking? And how does evolutionary literacy relate to other aims in either formal or informal education? So you can take that in either direction if you, as you like. And we can begin with Kostas.
Thank you. So I think Ute nicely set the stage with the reference to Douglas Roberts and the distinction between science literacy and scientific literacy. This is a distinction that they later make with Roger Bybee in their chapter, which corresponds to Vision 1 and 2. And I would actually take this distinction further, and I think, and that's the topic of my presentation, we need to define clearly evolutionary literacy, which corresponds to Vision 1, and science literacy, and evolutionary literacy, which corresponds to Vision 2. In short, these are literacy in evolution and about evolution, which means what we need to know and what we can do with this knowledge. And my experience as a teacher and a teacher educator for the past 20 years has been that we usually focus on the former. We don't teach at all about literacy, both because systems are focused on exams and assessments and textbooks and things like that, but also because evolution is a very, very controversial and counterintuitive topic, which requires special preparation on behalf of the teachers. So, unfortunately, I would go as far as say that it's quite difficult to teach about evolutionary literacy because the demands go beyond the scientific content per se, and I will elaborate in an hour or so.
Great, thank you. And we'll go through this round of questions, and then if there's questions from the audiences. So, Yosef?
Yeah, so my perspective as a scientist, when I think about what scientific literacy is, so for me it's like two different things. On one hand is the process, and on the other hand is the content, right? Or this is how I think about it. So I think it's very important to communicate, or that people understand what is the process behind science. So for very basic things, that science is based on observations, on facts. It's not based on beliefs. That science is a curiosity-driven process most of the time. I mean, we scientists, like, we pick a question that motivates us. And of course, we specialize more and more when we go up, like, in the knowledge ladder, but we never lose the curiosity. And this is what drives us to do science. And yeah, and a third thing, also very basic, I mean, science is about hypothesis testing. So I think these concepts, to me, it would be very interesting to try to convey them to the general public. And then there is content that it's also interesting, but I would say, in my opinion, it's like it's a second level of importance. I think it's more important that society understand the process of scientific knowledge. And regarding the content, I think it would be interesting to communicate that knowledge accumulates and that often it leads to changing perspectives on things. So it's not something, I mean, we build on previous knowledge, but at the same time we are creating knowledge and revising previous knowledge, which is very, very different from other processes that are not scientific, that are not based on facts.
Great, thank you. So now we'll go to Ute.
Yeah, thank you. Yeah, this is a very, very broad topic, and I think we can fill the next 2 hours without just with talking about this. I would like to stick to both the lady who talked. I'm sorry, I didn't get your name, and Kostas. I think from a science educator's perspective, perhaps we look at science evolution or evolutionary literacy a little bit different than a scientist, an evolutionary scientist who is doing pure evolutionary research. But I also agree that the process is very, very important as a part of an element of evolutionary literacy. But in my view, we have to broaden our perspective when we are talking about evolutionary. And I'm thinking that I'm more on the side of the evolutionary literacy if I stick to Kostas' definitions. Because when we are talking about literacy, we can not only look at the topic, at the discipline, at the context, not only at evolution as a scientific field, but we have also to take into consideration the person who is developing the scientific literacy. And therefore, for me, besides knowledge about the process of science and the knowledge about evolutionary principles, scientific literacy also comprises being motivated to use the evolutionary theory for explaining the world, and also the volition to think about evolution and its meaning for my personal life and also for society and for the global community. I think this is very close to the pandemic problem. This could be linked to this. So it's not just evolution as the topic and the principles, the key concepts, but also developing an attitude towards using evolution concepts for explaining the world to myself and to give me an instrument for decision making. Like right now, shall I have a vaccination or shall I not? Shall I have it not? We have the same with climate literacy. This is another field where we are also struggling. What do we mean by this? And people from psychology in Germany, at least, they frown because they say, but scientific literacy is it? And we say we have to differentiate this. But I think it's not only the content, it's also motivation, volition, attitudes, acceptance. For me, this is also a component of scientific literacy on evolution.
Great, thank you. Sílvia? Oh, did you want to add something?
No.
Okay.
I just wanted to say that's it. Yeah. Okay. Sorry.
No problem.
Okay, in my point of view is a bit different because somehow I have more general. We have had a lot of discussions about this thing of what should and shouldn't be taught and which paper has to have different fields in compulsory education in primary and secondary school, okay? I'll tell you the conclusion and then I will shortly explain you the why, and I suppose we can develop later. Somehow I've checked if evolution was not very present in primary and secondary education, and the answer is you are not so present. In fact, you are not explicitly present in primary education, at least here. And you are in secondary education, but in short parts, and the great part of them are optional parts, not compulsory parts for everybody, okay? So my way to look at that is it that presence enough? And my answer is probably is it enough, even if I understand here everybody would agree it would be better if it was great. But we've got a problem with curriculum. Everybody says things should be added to the curriculum, no one takes things out, and not everybody can fit in. But the second thing I've got the impression is it could be the presence you've got in the curriculum could be much better used, okay? Because in fact you've got, and I'll tell you why. You're theoretically one of the big parts of science. When I look as a teacher at the 10 big ideas of science, you've got one for evolution. I mean, you're one of the 10 big ideas of science, poca broma. But that doesn't fit with the amount of with the importance you've got. It looks as if you've got less importance in the curriculum than the one you're supposed to have as one of the main ideas of biology, okay? But you are a really good, you as evolution, evolution is a really great context to use with other disciplines because you interact a lot of with human, with social sciences, okay? You have some part that touch there. You have a great interaction, and you have explained it with mathematics, with randomness, with probability, and with all this part. You've got a lot of things that you can interact with, and that make you a really good context that can be introduced even when it's not explicitly put in the curriculum. And the third part, related to scientists who work in evolution, we need in primary and secondary education role models of people that is working currently, and as a field, evolution is one of the fields that's evolving. I mean, from physicists, we have some SMBE, because you have made big changes in the last second half of 20th century, and physics have his big explosion longer time ago in the first part. So there's a lot of people working on physics, of course, and on chemistry, but we don't have very important figures. We don't have very important things we are learning now on physics and on chemistry, and you've got really important things we are learning in evolution, and I think that's something it has to be put in value. I don't know how to say it.
Great, thank you. So I heard a number of great ideas in here. I heard that there's different ways to kind of parse out what is scientific literacy, that we can think about this in different ways, that it's going to have multiple elements or domains. So thinking about the pedagogy, thinking about what's happening in science as it's practiced, thinking about perhaps the whole student, the student's motivations, and then of course the relationship to all of these other disciplines, which is, I think, a major theme for the conference. So I thank you for these views. Are there? Does anyone have questions? Yeah, I see a question. Is that Chana, I think, in the back, or I might be? It's hard to see.
Justin?
Yes.
May I ask something linked to what what was just said? Because
yes.
There was this sentence. It's evolution is a good context, if I understood this correctly, and I'm asking myself, is evolution a context? For me, it's not a context. For me, it's an explanatory framework, more or less, for everything we are, more or less, everything we are talking about in biology. But I didn't want to disturb your
it's great.
But it was just because this is, for me, really something that hits me. So is evolution a context?
Well,
Kostas.
I don't know if Kostas wants, if you want to answer.
No, sorry. No, sorry, I'm not the moderator.
For allusions, okay? Okay, we can discuss if context is the right way. What I mean by context, I mean, for example, in primary education, even if you are not explicitly in the curriculum, even if in the curriculum doesn't say you have to teach evolution, you can use evolution. I know evolution is not just a context, but you can use evolutionary problems or evolutionary questions. You've said something that I think really interesting. Well, wait a moment. You can use this kind of questions or, sets to work, for example, with the general way science works. I think that's crucial. You said this idea of teaching curiosity. Teaching science is a way to look at the world, not the only one way, because there are many others, and students should know all them, but as a way to look at the world that's valid for a lot of things, dealing with curiosity, dealing with respecting reality in the sense that if data says something and you don't like what data said, sorry for you, but data said what they say. These things that if you're a really important man and you said something, I'm not so important, but data agree with me, sorry for your importance, but these kind of things, they're really important, I think, to teach to students. And evolution is a good, well, not context, if you want a good feel, you can introduce them there to use that. In that sense, I was saying. Even with their dangers, because you've got a story, I mean, eugenesis and social Darwinism is a part of what something same. You've got the controversial part, you know, it's not as easy. There are some subjects that are more like blunt, that you will have no problems in them. If I introduce mechanics, Newtonian mechanics, nobody's going to discuss me. You know, you are polemic, and that has their, we'll talk in the next question, but that has their advantages.
So would it be safe to say then that evolutionary theory is a explanatory framework, but all of the practices and all of the cultural aspects of the scientific use of this framework, this is a context in your view for education?
Yes, in that sense.
Okay. And does that get at a little bit at your question? Okay. And Chana in the back?
Yes, so first, thank you very much for this great roundtable and for putting together people from such different fields which have these very different perspectives which are really complementary and really important. And so I had a couple of questions. I'm not sure if I'm going to pose all those, so stop me when you feel you should stop. The first thing that triggered my attention was Kostas' differentiation between evolution literacy and evolutionary literacy. That was really important to, well, so we never use that, and thank you for bringing it to us. We usually use evolution literacy when many times we are talking about evolutionary literacy according to your definition. And I was surprised by what you said of being more difficult to teach evolutionary literacy than evolution literacy because of the, for example, acceptance problems. But I would argue, and okay, no scientific basis here, or some probably, that when people are learning in the context of, for example, a social problem that is important to them, that can break out some barriers in terms of acceptance, because that particular problem is important to them. They are motivated, like Ute was saying, to learn more about this because they actually want to solve it. And we can be talking about climate change, or we can be talking about very local things that I cannot even at the moment think of. But I would argue that possibly, and again, not sure which is my scientific basis to argue for that, so correct me if you have a scientific basis to correct me, but I would argue that that would build on students' motivation to learn and probably would help with acceptance problems. And the other thing that I would like to point out is, thank you, Sílvia, for highlighting how, so something that is, everybody is saying and complaining, and it's true. I don't know about other countries, but in Portugal, we only put things on the curricula and never take out. And this leads to the 10 miles long, 2-inch depth curricula. So in the end, people doesn't actually learn about nothing. And this is really important to highlight. And also what you said, that we can profit from things that are already there. The question is, how can we do this? So taking advantage from the contents that are already there and include the evolutionary framework or perspective, or as you prefer to call it, to teach also about the evolution key contents. I think that's a question that we also need to find out how to solve, I would argue.
So is the question, how can we, what's the role of kind of conceptual depth?
Two questions. So,
okay.
So shouldn't the contexts build on students' motivation to learn and probably help with acceptance problems, for example? And the other is, how can we take profit from what's already there? Because what's already there, it's many times it has actually been there for many times, and it didn't build on students' evolutionary literacy. So how can we profit from the contents there to build on students' evolutionary literacy?
Okay, so I will refrain from saying anything about evolution and evolutionary literacy because I don't want to give superficial answers, and I have a detailed presentation for this. But for the other questions, I think the answer is one, and it's the same answer to all questions. Teacher education. There is research that shows that teachers have serious misunderstandings of everything, and the people to blame, I'm sorry to say that, are the science departments. The way science is taught, the reason that scientists are not motivated to communicate, to be involved in science communication because they have to apply for grants and publish papers. And they come to us, the teachers with whom I work have masters in science, some of them have PhDs in science, some come to schools after doing a short career in research. But when it comes to the key concept that Ute mentioned, pedagogical content knowledge, we have serious problems. And then we don't have sufficient time to prepare them to deal with how to teach the content knowledge that they know in an appropriate manner so that they address students' concerns and misunderstandings. An important issue is that there are two kinds of obstacles when it comes to evolutionary theory. There are conceptual obstacles, but there are also emotional obstacles. And they have to do with worldviews. I will mention racism and religiosity in my presentation. And these are two things that a biology teacher would have to address, but it's not simple and straightforward how this can be done. So all in all, I would say that what we need to pay attention to is how teachers are prepared, and not only before they go to schools, but also during their career, to deal with these issues, especially as biology is changing. I mean, I was a student 25 years ago, and most of what I learned then doesn't stand anymore. Things have changed enormously.
Great, thank you. So I think that sets us up actually to go into the second short question. Oh, Ute, yes, sorry. Yes, Ute.
Dustin, if I may, I don't want, you are the leader here.
No problem. We have plenty of time.
So I think what Jana was addressing is very interesting, but I think it's not so focused on evolution only. As Kostas said, we have empirical validated knowledge from educational sciences that show that if you teach, it's in particular reasonable to link to the pre-knowledge, to link to the preconceptions. And this, of course, counts for evolution, and this is what I showed in my presentation. All these studies about preconceptions about evolution, there is so much knowledge, and I think that it would be necessary that university in higher education, the colleagues that are teaching the disciplines should also sometimes read a little bit about that, so that they are more successful perhaps in teaching the evolutionary concepts. And another point that is relevant in this context is to link to the everyday understandings as well, because some people, they have the disciplinary concept in their mind, but parallelly they have an everyday understanding, and this is conflicting these different conceptions. Therefore, it's necessary also to stick to or to link to the everyday understandings. And the question how we can help the students or support the students to apply the knowledge. And I think this is also something that is relevant for the evolutionary literacy. We know from research that it's helping that you combine knowledge and learning of knowledge and learning of particular practices. So not only to try to develop factual and conceptual knowledge solidly, but also combine it with activities, and this in science lessons, it's scientific practices like doing an experiment, order different species to different categories. So really always combine practices with knowledge. Then it's more successful to not to end up with lazy knowledge or active knowledge in the brain, but knowledge that can be used later. Yeah, that's it.
Great, thank you. So it seems that some of these challenges are going to be challenges that are facing the education system as a whole, and then we've also got a set of challenges that might be more specific to the conceptualization of evolutionary theory. And I think that sets us up to go to this next round of questions. Maybe here we'll start with Sílvia and go down this way. The second round of short questions. What areas do you see as the greatest opportunities or challenges for teaching evolution? And how should different actors or different sectors in evolution education, formal or informal, support each other with the aim of scientific literacy?
Okay. And some of the things I'm going to say, I think, are related to the second question you did, Shanna. I think you've got three great advantages, three great opportunities in evolution. Well, the first one I've already told. You're an important part of biology that is currently developing, so that's one big point. The second one is, I don't know, you're sexy as a discipline, you're attractive. There are disciplines that I don't know why, when you talk children about them, they get excited, and there are disciplines that are boring. And I came from physics field, and I don't know, thermodynamics is not especially attractive. I don't know why, because I like it, but people, let's make thermodynamics, nobody says, bleh. You say, let's make astronomy, and they get crazy. They begin to ask questions and questions and questions, and everybody's interested in black holes and things like that. And something similar happens with evolution. Maybe in his more, what we were saying before, maybe in its more difficult parts that are human evolution, but they're interested in that field. So that's one big advantage I think you can use. And the last one I've already told, you are really good, you have relationships with them. You are significant for children. Theoretically scientists said relevant contexts for children are those that are close to them. I never finished to understand this, because following this, this rule, children should be crazy about, I don't know, altered current that they've got all around them, and they don't get crazy about altered current, I can tell you. But they get crazy about dinosaurs. They haven't got real dinosaurs in their room, so there's something missing there. But anyway, you are significant in healthy issues, which lately are important, and you are significant too in all this field of animals that's really attractive for them. So you are significant. You have links to social problems and to history and to these things about having problems with religion is a problem, but it means too you can use evolution to deal with this problem. You have to talk with children. What happens when you believe one thing and religion says and science says another one? And what we have already said, it's good to see how science works in general. There are other fields that are good for it, but you have this advantage. Regarding to this advantage, very short. First, you have a crazy amount of misconceptions related to your field. Every field has, but yours, I've looked for misconceptions, and I found a list from Berkeley of 30, I can deal with 3 or 4, but 30 misconceptions, really? Yeah, 30 misconceptions that are really located. Second, that general in science, the culture of teachers about science is not very good, especially when dealing with primary teachers. Some of them are really genial about it, but in general, not all of them. A lot of them come from human studies. And people who study humanity doesn't study science, we scientific don't study too much humanity, but humanists don't study science at all, which is a problem. And even with secondary teachers that don't belong to our field, okay, that are from other fields. And the third disadvantage, that may be an advantage, is what I already told you. You are controversial, which means, in general, teachers, if possible, tends to avoid the subject if they're not especially interested. As a teacher, you're not especially interested many times in problems that can produce a father coming to complain to the headmaster saying, this teacher is teaching something that I don't want my son or daughter to be taught. Okay?
Great, thank you. I guess we'll go to Ute in the middle, if that's okay.
Yes. I don't feel so good because when I look on my monitor, on my screen, I see me very huge, like God sitting above you, and I don't like that.
That's how you look here too.
Can you make me smaller, please? Okay. So I do have 2 challenges and 2 advantages. Let me start with the challenges. I think one huge challenge for evolution, for supporting the development of evolutionary literacy is the high complexity of evolution. In my view, if you have understood evolution, you have understood biology. Because if you have understood the mechanism, the principles, the key concepts of evolution, you should be able to explain all phenomena linked to biological systems. This is the first challenge, so the high complexity. And the second challenge is that human beings have developed different kinds to look at the world and to explain the world to themselves. Like the Aborigines have other ways to explain their surroundings, the nature, than a scientist in New York does. So, in the students learn many ways. In Germany, we say the Modi der Weltbetrachtung. So there are different modi that we look, lenses, how we look at the world. Religion, for example, is another lens than science. And when you are in the classroom, no matter which level, primary, secondary, or even later at university, in higher education, you find all these other lenses as well. And the teacher has to cope with these and has to have arguments for his or her evolutionary worldview. These are the 2 challenges. And advantages, for me, evolution is the framework for evolution teaching. And this helps a lot. If I succeed in my teaching biology to make my students understand the basic principles of evolution, I think then the whole fields of biology to learn are going to be smoother and easier. And the second advantage, but this can also be perhaps a disadvantage, but I see it more as an advantage for teaching. This is the fact that when we are talking about evolution, we talk.
I think we just lost you for a moment.
About the students themselves, because when we are talking, am I back?
You're back. Now you're back.
Hi?
You're back.
Do you hear me?
Yeah, we can hear you.
The second advantage is, I start anew the second advantage, because I don't know what you heard. The second advantage, in my view, is that when we are talking about evolution, we have the chance to talk about the students themselves as human beings, and human beings as a product of evolution in one sense, and in another sense as a factor that is changing the biological world. I fear that you lost me again.
No, it's okay.
Okay, I'm ready.
Great. Great, thank you. That was very interesting. And so now we'll go to Josefa.
Opportunities. I think it's so related to evolution or an evolutionary knowledge. It's so important, or it's the basis for so many societal issues that we are dealing with right now. No? So it might not be that difficult to find people that it's worried about biodiversity loss or the loss of particular species. And that's a huge opportunity, to teach them or to transfer knowledge on how biodiversity, I don't want to use the word created, but how biodiversity is generated, no? To explain them that all of us come from a single common ancestor. Adaptation to global change, resistance to pesticides and to drugs related to cancer. I mean, like, understanding evolution, it gives you tools to understand these other problems that are problems that we are facing right now. For example, we have an interactive workshop in which we try to use, or we use evolutionary knowledge as a tool against racism. So just by teaching, or not teaching, but sharing the knowledge that we have as scientists on the origin of human populations, so just presenting people with the facts, so what we know and how do we know this, how did we arrive to these conclusions about the origin of human populations, and that's super powerful, and people feel empowered against racism, because they see this problem from a completely different perspective. And I want to acknowledge that the idea for this workshop was of Roberto Torres, one of the organizers. And then, so a lot of opportunities, because it's very related to our daily lives. Challenges. So one of the challenges to me is how to reach people with very different backgrounds, and with very different levels of knowledge about science and about evolution. And another challenge that I see is that, yes, teachers, I think it's a challenge, because it's very important. I think evolution should be taught at the schools from very early levels, if you ask me. But then we have a challenge, is that we need to have teachers that really understand evolution so that they can communicate this knowledge to the students.
Great, thank you. So we'll go to Kostas.
Yeah. So I don't have much to add because all these ideas are great. So I'll try to contribute to a more general thinking about challenges, opportunities, advantages of this. First of all, does anyone in chemistry ask why we have to teach the periodic table? Many people may hate it, but there's no question about why we can teach this, because it's something fundamental. And I think the same is the case for evolutionary theory. I will answer the question by go on the opposite side with an anecdote that might be interesting. So there's a lot of discussion, you mentioned earlier the curriculum, about whether evolution is included in the curriculum or in schools or not. Well, I would say it doesn't have to be, because if teachers are well prepared to talk about evolution, they can do it everywhere. Whenever they teach about form and function in physiology, whenever they talk about ecosystems, or whatever you want, they should be able to mention how and why we have what we have. But the problem is to do this effectively, and here is the anecdote. So I was a school teacher in Greece, and I started my PhD in evolution education in part because it wasn't taught much or at all, and I wanted to address the issue. So I was in a private school, very fortunate to have a lot of resources to use. And on the first year, I reversed the curriculum. I bring evolution right from the start, at the start of the course, 14 to 15-year-old students. And I gave them a good booster shot of evolutionary concepts and thinking and everything, and then switched to the rest of biology. The results were horrible. And when I read the answers, I realized that there is a reason that evolution is in the end. Students need to understand a lot more before that. They need to understand how ecosystems work. They need to understand heredity. They need to understand the structure and function of organisms. So in the end, I put evolution back in the end, and I tried to structure a curriculum in order to arrive at an understanding of how to explain nature in evolutionary terms. So all I'm saying is that we have opportunities to teach about evolution, in my view, in every course. There's no need for a chapter or a session on evolution. We can talk about it everywhere. The problem are the challenges, and the challenges are broader than we are. And this is why I said that the answer is teacher education. Attention, I didn't say teacher training, because education is different than training. And we need to educate teachers to be more thoughtful than what they usually are about these issues. And let me give you an example. Which are the main topics, scientific topics today about which there is resistance? Climate change, vaccination, human evolution. What is the common underlying thread? The problem of uncertainty. What people do not understand and cannot deal with is the uncertainty that is inherent in science, which, as we argue in a book, it actually makes science advance, because it's this uncertainty that keeps scientists asking questions and opening doors that have 10 more doors behind, and so on and so on. And interestingly, the reports of the IPCC show for climate change that uncertainties become more and more and more because we understand better and better the phenomena. But how can we communicate this to people, to students? That's the hard part. And the answer, that's a quote I mentioned yesterday, and I like to mention it, comes from Georgi Gerenger, a psychologist in Germany, who said that a big problem is that we teach students the mathematics of certainty, Euclidean geometry, and not the mathematics of uncertainty, which is statistics. So I think that we have broader issues to address in education about scientific literacy more broadly, about an understanding of how science works, what we say in science education, the nature of science, which would affect evolution, education, and understanding enormously.
Great, thank you. So, So a lot of challenges and opportunities. It's impossible for me to summarize everything, but some of the things I heard here about opportunities, at least, are this incredible conceptual structure, the conceptual framework of evolution that makes it such a, I think Ute was saying, such a powerful direction for teaching. And then many panel members mentioned, of course, the relevance for understanding our everyday experience, or for understanding what it means to be human, or for understanding some of those global pressing issues, from racism to perhaps other issues. And then, of course, on the challenges, what I'm hearing is almost a kind of mirror image of that, right? That Sílvia mentioned the challenge of interdisciplinarity, which will be where we go next to some degree, that perhaps evolution is not well integrated with the humanities, and perhaps humanities does not always know how to deal with sciences. And then, of course, I think many of you mentioned the systemic theme throughout the conference, I guess, has been these systemic challenges. So systemic challenges to teacher education, or systemic challenges to how the curriculum is even designed. Do we have any questions or comments? Does anyone want to build on any ideas here? Ute? Yeah. Ute, you can go.
Yeah. I would like to play a little bit Advocatus Diaboli according to what Kostas said. And this is the point or the aspect of uncertainty. Of course, regarding science as a continuous process to get findings about the natural world and ourselves, then at a particular point of time, our knowledge is imperfect. But in educational contexts, especially starting with very young children, in my view, it's a danger to stress at the first place the uncertainty aspect. Because uncertainty, and I have this discussion with my postdocs and doctoral students and my master students, in German language, uncertainty is often translated into Unsicherheit, insecurity. And in my view, this is totally wrong, this connotation, because the science knowledge that we have at a particular point of time is the best knowledge, in my view, that we can have. And in my view, the pandemic and the possibilities that the vaccination is giving to us is a very, very good example to show that. So in my view, of course, knowledge that science is offering to us and that science is elaborating is never perfect, and it's always getting further by our new findings. But if we go back historically at the beginning of science, the reason why people started to do these things to find out something about their surrounding and about the world led to science. And this was and is still a very, very valuable thing that humans have developed. And in my view, this should be stressed at the beginning. And in fact, we have facts that will not change, that the human germ cell has 23 chromosomes. I doubt that on the long run, someone will show that it's wrong. We are going more and more into details. Our findings are becoming more exact and more exact because of new techniques. But saying that all our scientific knowledge, I'm exaggerating, I know, is uncertain, is, in my view, bringing the learner into the wrong direction and even will drive skepticism against science. Ready, I'm ready.
Great, thank you. So what I'm hearing is that our views on nature of science itself may be a strong informer of how we think about teaching evolution. Is that fair?
You're asking me?
Yeah, I guess just a quick check if that sounds like a fair summary.
Yeah. This is, of course, this is touching the problem of the nature of science.
Yeah. And so we have a question from the audience. Johannes?
Yes, thank you. So this is extremely interesting for me because I am an evolutionary researcher and I come at education of evolution very naively. One underlying issue that I see here is evolution requires process thinking, right? And so fundamentally one problem that humanity has, and that's known, I mean, we're very early on in our lives biased against thinking about process and explanations in terms of processes. And so maybe I was very fascinated by Kostas' sort of distinction between evolution and evolutionary knowledge. But there's also a distinction between a very broad kind of what I would call evolutionary thinking in general about problems that are very general in terms of adaptive processes, which seems to be very hard for a lot of people, but goes way beyond evolutionary processes in biology specifically, right? And so I was just wondering what the panel was thinking is, in terms of this as a challenge of teaching children to think very, very fundamentally differently about problems in the sense of process thinking instead of, thing thinking.
So, Kostas, yeah, you can.
It's a huge discussion we cannot have right now. But I think the answer is in part in what Ute mentioned. So, of course, Ute is right that we wouldn't go to the first grade and tell them, look, science is uncertain. We wouldn't do that. And this is where intelligent design is useful in the sense of intelligent curriculum design. Curriculum design is very difficult, but I think we can adjust it so that we begin to make students have confidence in science, because as Ute said, is the most solid, rational kind of knowledge that we can have, but also show them that things are not always crystal clear. And one reason for the reactions against the pandemic measures, for instance, were that people are not used to dealing with uncertainty. But if you go back to history, in 1918 in the United States with the flu, the so-called Spanish flu, which is a wrong name, as you know, and that's just a weird reason that they call it Spanish. What they found in analysis from data since then is that the cities that took strict measures had less mortality than others. So there were things that we already knew. The question was how to communicate them to people in order to make them understand that this happens. Now, there are fundamental things that we can do. I have a suggestion that I've been making for 10 years, but nobody's listening in part correctly because I don't have any empirical data yet to show. We go to kindergarten and we tell kids about the distinction between living and non-living entities, which is, in my view, the second step. The first step would be to show them the distinction between organisms and artifacts, or actually natural objects and artifacts, which is the distinction between what is designed and what is natural. And once we separated artifacts from the rest, then there we can make the distinction between living and non-living, putting organisms in one place and rocks and clouds and everything in the other. Why? Because there's evidence in psychology that perhaps because we grow up from a very young age surrounded by artifacts, we learn that everything around us exists for a purpose. Just think when you were infants, how many natural objects were around you and how many artifacts were around you. Now, the idea is, and this is of course a hypothesis that I'm not sure the psychologists have a conclusion to that, is that as most of what we see around is an artifact designed for a purpose, with essences, essential features and goals, eventually we extrapolate that to nature. And that's a main obstacle that we could address. Ute mentioned the work of Deborah Kellerman. That's her argument, and I think it's in the right direction. So there are fundamental things that we can do from early on, and I entirely agree with Ute. She made the point earlier, the secondary school is too late. We have to start from kindergarten with fundamental distinctions that address fundamental problems like the one I just mentioned.
I just link it with what you were saying. I just wanted to point out things. First, you've said one thing that I think is really interesting. That's when dealing with teaching with children, we have to be, with teaching to children, or with children, but we have to have clear that there are things that can be taught at some levels. You cannot be talking about evolution as a long-term period to young children because for them, millions of years means nothing, absolutely nothing. It's impossible to talk about human evolution with really young children. They don't get that time problem. That it was something Ute said in his previous conference. And the other thing you said, Ute, that I think I'm pointing at the screen, not at you, is this question with probability, with uncertainty. You've got, evolution has a curious mixture between rules and randomness and uncertainty processes, okay? And that's hard to understand even for adults, and imagine for children. But I think there is one thing that we can use here. There is one environment in which children really deal well with this mixture, that are games. To teach evolution to children, I think games are good because games have just good-made games. Be careful, not every game is. But games have just this mixture of randomness together with the rules. And I think that's a good context, because if you try to go before time with things that are not prepared for them, that they are not prepared to learn, then you get misconceptions, you get weird things. There is a curriculum, I don't know if you know it, there is a proposed science curriculum in Victoria State, that's in Australia, but it's really good, where they make a gradation in different fields of which ideas you should touch first. They're great. I've downloaded the ideas for biology and I've looked at your field in that sense. And the ideas you should touch with children, it was the one you were telling. There are things that are artificial, animals are different, animals came from parents, they're quite similar to these basic ideas, they have to be first there before you go further. And I think you can check that. And the last thing, talking about uncertainty, I think it's not a question, I think that's a question that's difficult for everybody. I don't know if you know the book from Kahneman. Kahneman said that the Israeli, and he's a psychologist, he said every human is a genius in linguistic, but every human is an absolute disaster in statistical, just for the way we're wired. Statistical concepts, randomness, is hard for everybody, not just for children. We hate thinking in processes that don't have a reason, that is just randomness. Would you get COVID? Who knows? We hate that impression of not having nothing to do, that, you know, that we can influence. Are you going to win this or that? Who knows? It's random. That's something we dislike deeply. And, well, we have to be conscious as teachers of that. It's normal to have religion, don't have that. Religion, what you get is because you've win it, or because God knows it. You don't know it, but God knows it, you know? And that's not, that's a weird thing. Science, on the way, is not a natural way to think. You have to be conscious about that. Every culture has technology. Every culture has religion. Not every culture has science, the way we understand. In fact, I think we are almost the only one. And that doesn't mean science is not valid. Science is great, but it means it is not so easy to teach because it's not so natural. These things of the knowledge is the strongest knowledge we have, but we have the doubt as a method. Doubt as a method, doubting everything will give us safety. It's like, that's not easy. That's why, I mean, it's normal to have that difficulty.
Just a minor point, whereas Kahneman has shown with Amos Tversky that there are difficulties, Georgi Gerenger has also analyzed their work and shown that it's not only the difficulties that we have, perhaps it's not mostly any hard wiring that precludes us from understanding what is going on, it's also the way we frame the questions. And sometimes we do not make things easy for people to understand what we're asking. And we confuse them with percentages, whereas we can present things differently and make things clearer.
Great. So I think this also sets us up for the perhaps last set of questions. So Johannes was bringing up this concept of adaptation, both in the biological and perhaps human domain. And Sílvia was thinking about this uncomfortability. The experience of students is to be an agent in the world. And perhaps to be trying to adapt and create an adaptive environment. And we've been talking a lot today and these past 2 days about the meaning of evolution as it relates to being human. And I think one of the themes that's become clear in some of these sessions and in some of our discussions is that there's a huge amount of diversity even among this expert group, right? We have this amazing interdisciplinary expertise. And so what we wanted to try to get at in a more open discussion fashion is in the human domain, when we think about evolution and relating it to human issues, we have this diversity of opinion. As Sílvia said, perhaps the humanities are not well integrated with science in some sense. As Susie and I discussed last night, there's of course the evolutionary human sciences, which do that. And of course in evolution education, we're not always connecting these dots. And so, so I thought we could maybe have a more open discussion about what does it mean, from your view, could you describe your views on the role and relationship of education in evolutionary biology as it relates to these other disciplinary works, especially in the human sciences or the humanities? And how could formal or informal educators work together in this regard to support the aims of scientific literacy? So how do we take our evolutionary view of the world and relate it either to what it means to be human or human issues, human sciences, or the humanities? And this is open. Does anyone volunteer? Kostas?
That's a very important and a very important question and an issue that has caused problems all over. I think that science and scientists need a broader understanding beyond science. Anthropologists have been blaming evolutionary geneticists and population geneticists for implicitly and unconsciously supporting racism with their work, exactly because they do not perhaps realize that when we deal with humans, we need a broader understanding of what is going on. So actually, racism was supported by science at the end of 19th century. Then we had eugenics and the Holocaust, and you know the stories. Nothing to do with Darwin. It has to do with ideas that were spread all over Europe and North America. But even that, after that, and even after UNESCO provided definitions of race and everything, there were biologists like Dobzhansky who were against any kind of discrimination, but still believed that races are real, that they exist. And then later we had Luigi Luca Cavalli-Sforza and his project, the various projects he was involved to trace human genetic variation, which were based on assumptions that archaeologists, anthropologists, and many others would criticize. They went to supposedly pure isolated populations and tried to trace the genetic variation that they have in order to make comparisons with more admixed ones. So I would qualify, perhaps I'm Greek, my parents are Greek, my grandparents are Greek, everyone was in Greece as far as I know, but I only know for 2 or 3 generations what was going on, not before that, but they didn't care. Insofar as you have been there for 2 generations, that's enough. As if genetic inheritance goes undiluted on and on across generations, but this is not at all what happens. Furthermore, another assumption that Cavalli-Sforza made was that globalization and migration began with Columbus. He was very important, and the pace of migration was much more increased during the colonization era, but this doesn't mean that people were not migrating before. So all I'm saying is that eventually we had the HapMap project, the Human Genome Diversity Project, and other projects mapping human genetic variation on particular assumptions that do not stand from archaeological and anthropological points of view. And in this sense, unconsciously, scientists, geneticists have created the impression that we can support racial differences on the basis of biology. This is what people like Nicholas Wade and Charles Murray have done with their books, whereas this is not the case, much as the same geneticists claim in their articles that what we have found does not support any notion of race. So my point is that science is important, but when it comes to humans, we have to look at the broader issue. We don't care about Drosophila, perhaps, and if the race is there, but we care about one another. And what we know is that we are a huge family that has evolved for 4 seconds in a 24-hour period. And this is something that we can transmit to students, I think.
Great, thank you.
Okay, I'm gonna go a little bit against you. Not against you, but I mean, what you said is it's true. But I think this, okay, how can I say this? I'm being politically correct.
Just to be clear, I'm not blaming the geneticists for being racist.
I know.
But there were people who took advantage of this work,
that's a
which
different
was
thing.
misunderstood because they didn't think of the broader questions.
Okay.
Or because they made assumptions that do not stand from other points of view.
No, I was going to say that I think that I haven't done any study, but I think that the majority of the population biologists or population geneticists don't believe, and they defend that there is no genetic basis for races. So the fact that some people, do, or even they were misinterpreted and used as an excuse to foster the idea that, there are differences, genetic-based differences between human populations, I think it doesn't reflect, like the community knowledge. So I was going to compare it to global change. So global change, I think, I don't know the percentage, but a very, very high percentage of scientists think that we have enough data to conclude that we are in front of a global change that is caused by humans. Of course, you are always going to have small percentage of scientists that are going to go against this, but like the community as a whole, it's in favor. So I agree with you now what you are saying, that then some parts of society or even journalists are going to give voice to this small percentage of scientists that are going contrary to what the whole community is thinking, and this can be misinterpreted, right? And used even to go against views that are clearly established in science.
Well, here's an interesting story. There's a study by Anne Morning with biologists and anthropologists back in 2008, whether they believe that race is biological or not. And I assume she was expecting that biologists would say yes and anthropologists would say no, but the funny thing was that half of them said yes and half of them said both biologists and anthropologists. She was thinking that perhaps it's the discipline that makes a difference, but eventually it's not. Now, I don't know of any large-scale studies. That was a study with 40 scientists in the United States, if I remember correctly. But the whole thing is that it's not about disciplines, but eventually the point stands that we need a broader discussion, a broader collaboration. And actually, there are now centers of what they call paleogenetics, at least in Germany. I can think of one where archaeologists and anthropologists and geneticists work together to bring new ideas, bring forth new ideas. And I think this is what we need: interdisciplinary, transdisciplinary, and multidisciplinary collaborations, not just isolated studies that ignore one kind of scholarship over the other.
I completely agree. Yeah.
Could you just comment further? So you mentioned Cavalli Sforza, who developed this critical work on race as not a biological construct, and then of course part of his work has led to the now robust field of cultural evolution science, which is also has scholarship around potentially the cultural evolution of racism or anti-racism. And so that's been a bit of a discussion here. When we think about evolution education and interdisciplinary evolution education, how are we reading out that history? Should we, in your view, is that gene-focused thread the way to go, or do you also see value in Cavalli Sforza's other work?
I don't know. That's a hard question, but I would say that there are a number of books that make these arguments. Jonathan Marks has written the book Is Science Racist? A journalist, Angela Saini, has written the book Superior. I think is one for race or inferior. One for sex, one for race. I think Superior is for race, where they make the claims and they show the evidence that science has, again, unconsciously and implicitly supported these ideas because they're not framed in the way they should be framed. Now, here's the big challenge. Can a biology teacher teach evolution and address all these issues? I don't know. That's very hard, and that's actually one of the problems I'm going to describe about evolutionary literacy. that it demands knowledge and understanding that goes beyond the undergraduate studies in biology that the teacher usually has.
No, I related to this last issue and talking about interdisciplinarity, sorry. I think that's an issue that's in discussion between the community of teachers. If someone wants to make a scientific research, it would be nice to have someone saying something more than an opinion. But there's people that thinks that you have to teach your specialty, you know? To teach evolution, you need a biologist, full stop. That's one extreme of the spectrum. The other extreme of the spectrum is everybody can teach everything. You are teaching children, you're not teaching such a complicated material. So if you're asking for children to understand something that you are not able to teach, we have a problem, you know? you should be able, okay? And there is a lot of people in the middle. There are problems with interdisciplinarity. There is no doubt about that, okay? And no, here, in my opinion, and it's just an opinion, that's a problem. There are too much opinion in this field. In my opinion, I think, especially in secondary education, we are too attached to our field. Obviously, it's the field you prefer. I mean, if you finish up studying biology because you love biology in general, you know, so you love that field, you have a personal relation with the field. But you know, I always say, the day they give you the title, they didn't take out your brain, I hope. So you can learn more things. There's some people that act as if the only period in which you can learn things is that 4 years you are in the university, and once you are out and you're a biologist, sorry, you cannot learn about social sciences, you know? It is not that way. Anyway, it's hard, it's not easy, you know, because not for learning facts, which are easy to learn if you have a minimum interest, but for having to learn that way to look at the world, which is not so easy to transmit. And in that sense, when talking about interdisciplinarity, we need something from scientists. We have to ask something for you. I think we need a clear, or as clear as possible, explanation about what should and especially what shouldn't be taught. I mean, we make mistake if we learn on ourselves and on our intuition. But I think you are the one that have the knowledge to say, wait a moment, when you have to explain about evolution, what you cannot say is, I don't know, that competition for the strongest is going to be, that you cannot say because it's not that way, because this, and I can understand, it's not so difficult to understand that concept. I just cannot take out that concept out of all the field of evolutionary, because I don't know all the field. That's something you have to do. And I think that could be helpful. In collaboration, that field I told you, I'm working lately, when you try to make a collaboration between teachers and scientists, the best thing you can bring is that thing that, as a teacher, I have an idea about what to do in my classroom. But when I explain it to you, maybe you say, wait a moment, this thing you are doing is not what you are supposed to be doing. You cannot say it that way, you have to. And that thing, having that help, it would be really useful. Having activities, so I thought, I don't know who I was talking about the other day, that they were saying, we teachers cannot create everything we do in the classroom just because we have no time, okay? Then it's good to have good activities, and there are a huge resource of them. We have seen some of them here. We have seen, there are in our resources, I know, in the local field, I know the material that was constructed during the Darwin year, that's really interesting. We have centers for, specialized centers of resources that can give you material, but it's important if that material is constructed between people who has the knowledge, teachers, and then have some freedom for teachers to adapt. And being very specific in that aspect, I'm not, obviously a language teacher, but I've got a good language teacher telling to me, Sylvia, you have to go to a classroom and you have to teach, argumentary text, and you have to be careful with this, and with that. And I've been able to do it. And I've got the teacher teaching robotics. I took her and said, come here. You have to be careful with, of course, she needs me at the side, but it is possible. It's possible, but it's difficult, which means you have to be conscious. You are asking for an extra effort to teachers when you ask to be interdisciplinary. Anyway, it's the only one way you can deal with real world and real problems. Because real world is the example you were saying, you cannot talk about racism just as a biological problem. You cannot talk about, well, you can, but you miss a part if you talk about racism just as a social problem, as if science has nothing to say about. We need to collaborate in that. The big problem here, there are two big problems. One, time, and second, mental barriers. We are comfortable with our, in our field with our similar people.
Yeah, we'll just jump. We'll get to Ute, and then we've got a couple audience questions. Yes, Ute.
Okay, thank you. Perhaps I see it a little bit differently than Sílvia. And I would like to take another perspective, and this is the perspective on teacher education. I think there is no doubt, and we have enough data that show that the content knowledge, in our case, the biological knowledge, is absolutely relevant and necessary to be a good biology teacher. And we have the correlation between the content knowledge and the pedagogical content knowledge are very, very high. And pedagogical knowledge this content knowledge is a mediator for the development of pedagogical knowledge. So I think that a biology teacher has to have a very profound education in biology, there is no doubt. The question that Dustin was raising in respect to all the different subjects and the interdisciplinarity, in my view, we have to go back a little bit when trying to discuss this into the history. How did these subjects, school subjects, came up? Why were they implemented? Why do we have a school subject about music but not gardening, for example? And this is related to what I tried to explain earlier about the Modi der Weltbegegnung. It's a term implemented by Wilhelm von Humboldt, and it's related to the school subjects. Because human beings have different ways to express themselves. And we find this fact in subjects like arts, like literature, like sports. And also we have different epistemologies, and these are reflected by humanities versus or complemented by science. And in my view, each teacher, no matter what subject he or she will teach, should have such a course in the beginning of his or her studies where these kinds of more epistemological aspects that are behind and the foundations of their subjects must be educated to implement an understanding what is the aim of the subjects. And then when teaching, also make relationships to the other subjects, but at the same time make understandable or make visible that each subject has its own right of its existence because it does something totally different. Yeah.
Great, thank you. So I think that really rounds out the continuing theme of this conference in terms of interdisciplinarity. That there's different views of opinion, and I think Sílvia said it nicely that actually Sílvia and Ute both highlighted that perhaps there's a social emotional competency that we need as scientists about how to think, how to relate to disciplines, some level of maybe intellectual humility or perspective taking when we're talking across disciplines in this evolutionary way. So this is the scheduled time for the end of this session. I think we had a few questions, but I think we'll just have to spill out into the hall, and Kostas' talk will be coming up, which will also build on a lot of these themes. So I hope we can continue this discussion, and thank you all for attending.